Oh, g'day guys, how you going? Today I'm going to be looking at the application of a moving coil loudspeaker. Now, in terms of a moving or current carrying wire inside a magnetic field, there is an automotive force that's actually produced. Right, so this is fairly similar to how a electric motor works, right? But obviously the application is a moving coil loudspeaker. So if you look at here, we've got a cutaway of that particular speaker. You can see the voice coil there. That's actually very fine wire, very fine. Obviously you have lots of loops around that particular coil, and therefore that's also very close to the fairly strong magnetic field there, permanent magnet that you actually have in here. There's a lot of other parts of that which we don't need to worry about. So if you're looking at, we'll represent that as a moving, the voice coil there on that side, and then we'll look at the top view over here. So you see the south and the north part of the magnet, the pink voice coil which is sitting inside there, and that actually moves up and down. Alright, so that's essentially how it works. Just another side view of that. So if you're looking at the speaker cone, you've got the voice coil there sitting around, right, and it goes in and out there. So what I've done is I've actually drawn a very simple schematic with this. So what we need to look at is how's this going to work in terms of the physics behind it. So if we start thinking about the this particular situation here, so this is our voice coil. So the cross means it's going into the page, the dot means it's coming out of the page. So over here, if you use your right hand, so your field lines are your fingers, so put them there. Your thumb has to be going in the direction of the current, which is into the page. That means that your palm will be facing upwards, and so therefore your force is directed this way. We come over to this side over here. Alright, your field lines again are your fingers. Your thumb has to be coming out of the page, which is your current, and again your palm will be pushing upwards. So therefore that means that the force is coming up this way. Now all I do in a moving coil loudspeaker is I change the direction of the actual current thing. So now using your field lines, so this one means that it's coming out of the page, and this one's going into the page. So again, it's field lines there, your thumb coming out of the page, which means your palm is pushing downwards. Okay, so therefore that's where our force would be directed, down this way over here. And again on the other side, your thumb's going into the page, field line's going towards the south, so therefore you've got a force coming down here. Right, now if you think about the hearing range for humans, hearing range goes somewhere about 20 Hertz up to about 20,000 Hertz. Right, so if you want to produce a sound in that range, what you need to do is you need to change the direction of the current in that voice coil that many times a second. So every time it comes, obviously, every time it sort of moves in and out, you're actually producing a compression wave. So all we do to actually make that sound is we alternate the current to whatever frequency that we actually need. Right, so that's simply how a moving coil loudspeaker works. Right, it's a pretty simple example of that. Now that would be one that you'll probably need to know for your test. Right, so to be able to explain how the right hand palm rules works there. Obviously the number of voice coil, or the number of loops that you got around there, and the current carrying in there will tell you how strong that force will be as well. Alright, so we'll look at another example of this in the next video, so I'll see you soon.